volunteers doing it?
Yeah.
Come to Jesus meeting?
All right, guys. Hey, I got 1 o'clock on my watch, so we'll go ahead and get started. I don't want to keep everyone longer than necessary. Thank you. This is such a great turnout today. I am so excited to be here. And how many of you are looking forward to Minden getting their own TAF? How many of you knew Minden was getting a TAF? All right, at least a handful. So it is starting October 22nd, I believe, at 18Z, which is 11 a.m. So look for it. We will be getting out with that.
It's actually already current.
We actually, yes, we are doing practice ones already. They're not official though.
Oh, they're not real?
No, they're real. We're really doing it, but kind of consider this our practice rounds because I'll kind of explain the limitations we have going on here. Anytime we start up a new site, we kind of need to learn more about the area. We have climatology to work off of, but we don't have the same amount of guidance that we would for, say, well-established airports that have been there a while. Apologize. Hopefully everyone can see, and if not, let me know. We kind of had to go through multiple iterations of trying to make this actually work because it was kind of a comedy of errors, but we got it to work. Anyway, my name is Dawn. I am a senior meteorologist at the National Weather Service out of Reno, also our aviation program manager. I have been at the Reno office for just over almost 10 years now, in the Weather Service for about 15 and a half. Interestingly enough, aviation is what got me interested in weather. No, I'm not a pilot. I don't pretend to be a pilot. But I grew up flying with my dad, who is a private pilot. And he'd always be checking out weather before going. And I was like, hey, Dad, what you doing? It was kind of interesting. And I think it kind of spawned my whole career, to be honest. So that's how that got going. But this talk will probably be just over an hour or so. If you have any questions, please let me know. Otherwise, we'll have kind of questions and answers at the end as well. We're going to touch on all sorts of things from kind of the local forecasting that we do here, our concerns in the local area, predictability, terminal aviation forecast, the TAF itself, METARs, upper air charts, surface charts, soaring forecasts, pretty much everything aviation that you probably didn't need to know. But you will know where to find it, and it's going to be some great info for you. So, things that concern me. Well, my 3 kids, but that's for a whole other talk, so we won't go there. Otherwise, it is making sure that pilots are weather savvy. I know when I came and spoke with the soaring group here, they said weather is everything to them because you're literally taking your life in your hands when you're going up there. Can I see show of hands? How many of you are soaring pilots? How many of you are pilots for small aircrafts, general aviation? Very good. So we've got a good assortment here. Anyone do helicopters, Civil Air Patrol, anything of that nature? Cool. Okay, we've got a great selection then. So what I want to make sure, though, is that all of you are safe. You have the best available weather information at your fingertips. We have all kinds of things to deal with here. Wind is the greatest factor in aircraft accidents when it comes down to weather being a factor in aircraft accidents. How many of you have ever had wind concerns? Yeah, me too. Yeah, the winds around here are a little insane, but we make it work. And just kind of some fun stuff from this winter. See that plane right there, Citation X? Nice heavy wet Sierra cement caused the tail to go down and the nose to go up at Truckee this winter. So things you don't want to see. So a lot of weather concerns with aviation. I want to make sure all of you are well aware of where to get this. Now around here, weather is rather chaotic. This is actually a time lapse. It's over only an hour-long period, and unfortunately, I know the details of it aren't particularly clear. There it is. But it's showing you, it's from the TV Hill Alert Tahoe camera, showing you just how chaotic the winds and the weather can be over just a course of an hour. Do you see the varying currents? Do you see how the mountains are influencing where the cloud movements are, or things are going? There's a lot going on there, right? And that's over the span of an hour. Mountainous terrain.
Is that around here?
Yes, so TV Hill is actually closer to Hawthorne, but same general idea. We've been able to get images like this off of many cameras before. I personally like this one because it had clouds. You're able to see the currents a little bit better. Would you guys like me to play that one more time? So you can watch clouds flowing. You see the flow patterns coming right around. And these are things that as pilots you're going to be having to deal with all the time as you're flying in mountainous terrain. So let's talk about some of our important weather scenarios around here. First off, we'll start with winter. So So snow character, wet versus dry. That's always a concern we hear from our airport managers about. Snowfall amounts, timing and duration, peak intensities, temperature, winds. You know, is the snow going to melt off? Are we going to be keeping it around? Is it going to be blowing around? And of course, the marshmallow man potential. That's always a concern for us, right? So when we have floods versus blizzards versus winds, we usually can kind of tell you more details 2 to 4 days out. Early on, we'll be able to tell you, hey, there is a storm coming. Maybe even with 7 to 10 days of lead time. But you know, knowing the details of it, it comes more clarity, if you will, within 2 to 4 days of it actually occurring. So in the situation where we might have the snow coming in, we might see a jet coming across the Pacific combined with an atmospheric river. If it comes up, gets cleared over the mountains, we will usually end up with either heavy rain or snow depending on temperatures ahead of it. Now, same scenario, but let's say instead of it flowing across, we have a different type of stability parameter as you cross over the mountains and you start getting downsloping winds. So that's where we get our windstorms out of. So we can see things looking very similar going into it, but once you get down to the details, it depends on how that airflow is crossing over the mountains. And that'll lead either to you getting some heavy rain, heavy snow, or getting wind out of the scenario. Now, snow level predictability is rather difficult. You know, I'd like to say that, hey, we are awesome, we do great on snow level forecasting. And truth be told, if we're within 500 feet, I'm kind of thinking, okay, thumbs up. But 500 feet can yield incredible differences to those who are concerned with it, right? So I know this is a little bit small, and sorry, I kind of was thinking big screen here, but you can see some of the snow totals there. Let's say around Lake Tahoe, 1 to 2 inches. Let's say the rain snow line's about 5,800 feet. Let's take that up now to 6,500 feet. All of a sudden, we're dealing with no snow around there. Mountains are getting a lot less. Donner Summit, we had 8 to 12 inches. Now we're looking at more like 3 to 4. And let's go on the other side now. We're going to go 500 under. And now all of a sudden, you're looking at 8 to 12 inches of snow at the lake. So 500 feet doesn't seem like a huge difference. And for us, snow level forecasting is a pretty good deal, but it yields incredibly different results for anybody who's concerned with it. Now, one of the least predictable hazards we have is actually the next one, excuse me. It's when, this is actually not that bad. When we have a cold low coming in, we have a nice moisture plume, we know we're going to be getting snow here. We can get some of our heaviest snows. If anyone was around for the 2004-2005 snows, anyone raise your hands? Yes? Okay, cool. You guys remember how much snow dumped down in the valleys? Several feet. Yes, which out of the storms for here, it's pretty rare getting that kind of 2 to 4 feet in the valley locations. But that was a nice cold, unstable air mass that was coming in combined with moisture. Perfect scenario to get heavy snows into western Nevada. Now that's the one I was thinking about with the least predictable here. Inside sliders, for us, causes us fear because inside sliders are hard to predict. They come in from the north. They tend to have very limited amounts of moisture with them, but they yield incredible traffic hazards. They cause all kinds of problems for our aviation partners as well because all of a sudden we can get visibilities dropping to near nothing. And as far as accidents occurring, I mean just getting to and from your airports, trace to 2 inches of snowfall has been shown to produce the most amount of accidents out of anything. Seems like people slow down. When you get a whole lot of snow, people slow down, get less, and they still go fast. Other thing to look out for, the Tonopah low. It's when you end up getting an area of low pressure near the Tonopah region, we start getting easterly flow, and the east side of the mountains tend to get hit the hardest then. Lake effect snow can definitely impact things here down in Minden at the airport off of Lake Tahoe. We've seen bands of snow where you get just huge amounts of snow dumping down into this region. We can also get freezing rain if enough cold air gets trapped into the valley locations. And of course, the winds, as we were mentioning, big downslope wind events. If you see a sky looking like that, what do you think? Safe to fly? I personally wouldn't want to do it, but when you're getting those downslope winds, you get these really fast wind speeds flowing over a barrier. So here's our Sierra. Winds can't go through, it's got to be up and over. Depending on the stability of the atmosphere, it either ends up being trapped lee waves, propagating downstream, or you're getting breaking waves coming down the mountain. Think of a hydraulic jump in this case. So we're looking out for that as well. Here's an example of a windstorm. This was February 6, 2015. There we go. Now, this is actually looking from our office. Yep, you see the standing wave? Do you see the rotor? Right there. This is actually the Reno Airport right over there. So cases like that does not make for happy pilots. You need to look for those visual clues, look out ahead of time. I'm going to show you where to look ahead of time to know not to get into these situations. But obviously you can tell in this case, standing waves, rotors, things of that nature, you probably do not want to be up in the air. Maybe if you're guided gliders, you might like that. But that day, some of the PIREPs and ATC chatter we got from that, UPS plane coming in, and the tower asking them, how were the conditions? They said, we don't even know where to begin. An unknown airline to the tower, get me the hell out of here. Lots of extreme and severe turbulence reports. Actually, just this last winter, we had that pretty severe turbulence that caused an emergency diversion to Reno. I mean, how many times do you actually divert to Reno in a wind scenario? Not too often, right? Lots of low-level wind shear reports. And this was an especially scary PIREP when we heard that the wing was damaged due to 2 big jolts of turbulence causing the skin of the plane to wrinkle. So, we get some pretty good windstorms around here, and I want to make sure that you as pilots are well aware and are very careful with that. So 2 types of wind events that we're going to get. One's going to be the downslope. That's what I was talking about with the hydraulic jump, when you're getting those breaking waves coming over the Sierra. And there tends to be little or no impact from gradient mixing, so that's just kind of the general wind patterns. You're going to normally see gusts greater than 40, and extreme cases actually going through Washoe Valley, you know, all those lovely bridges that are along the new 580. We sometimes see winds gusting 80, 90 miles an hour over those. So downslope winds, it's going to be strongest right along the eastern Sierra front in those wind-prone areas. The other one that we look at is going to be gradient windstorms. Now, a gradient can be from a pressure difference or a temperature difference. We have a pretty good cold front that's going to be coming in on Sunday. So Sunday, going to be windy because you're getting a pretty good thermal difference, and that's going to be causing the winds to blow stronger. So with that, it's typical during transition seasons. We happen to be getting into one of those seasons right now, fall, right? And the strongest wind events, we tend to see gusts over 60. And like I said, watch out for Sunday. That's looking like a pretty good windy day right now. If we're looking at atmospheric rivers, everyone remembers the winter from, 2-3, I guess now we're coming up on 3 years ago, right? 16, 17? We had gone from 4 years of drought, and it was like, okay, how are we going to make up the deficit, right? And all of a sudden, one winter did it, because we had AR after AR after AR. Kind of became a dirty word in the office. Apparently Harvey's or Harris, one of those ones in South Lake made the atmospheric river drink, became a thing. So everyone got to be very familiar with atmospheric rivers. This is actually the second flood, if you remember that winter. Picture of the moisture going right across the Pacific. Now these are going to be very easy to predict, apparently like where they're going to fall along the west coast, but as far as the actual location, which probably going to take more like 5 to 7 days out. Summertime hazards, one of the things you need to look out for, heat waves, because of density altitude concerns, right? Now, I want you to kind of picture these boxes. This is all equal pressure. If it's cold air, molecules aren't moving as fast. They compress down, right? It's taking up a smaller amount of space. If you get into warmer moisture air, those particles are moving around a lot faster. They occupy a much greater volume. And so all of a sudden you're looking at a hugely different density altitude. So let's take Minden, feasible case here. 100-degree temperatures, 55-degree dew point. Any guesses on density altitude? Pretty darn close. And yeah, 8,600 feet. And there are calculators online, and I'm sure a lot of your flight software has it as well, and you're going to get briefed on it. But always make sure you're taking weight considerations when you're dealing with these hot days, especially if there's moisture in place. So everyone knows around here, summertime, what kind of winds do we get? Exactly, we get those westerly downslope winds, right? Now, if you're dealing with typical winds do not flow downslope in the afternoons. Winds should be flowing upslope in the afternoons. So what's causing that? Well, what happens is, out here in the basin, it tends to get incredibly hot. Now, along the Sierra, not quite so hot, right? So surface is hot. We have a lot of excited molecules, right? They want to rise. What does that do? It causes low pressure at the surface. Where it's not as hot, it induces basically a surface area of higher pressure. Now, wind flow is always going to be from high pressure to low pressure. So, you now have higher pressure along the Sierra, lower pressure out in the basin. There's your westerly wind that we get every single afternoon in the summer, unless there's something different going on that disrupts it. The strength of it is going to be determined by what the thermal difference is, because that's going to be showing you, remember we're talking about thermal gradients, so if there's a greater thermal difference, it's going to make it flow faster. Typically, we're going to see these kind of timings here. Truckee starting around 2, from about 2 to 6. Stead's about 3 to 7. Reno, Carson, Minden, about 4 to 8 is kind of the peak flow on it. Again, this can vary slightly on either side depending on the strength of the event, but that's what you want to look for. South Lake really isn't impacted by it because they're more dominated by lake breezes during the day, and then downsloping once you get into the afternoons, they get that southerly drainage wind. Other thing to look out for in the summer, of course, are thunderstorms. We're expecting a few of those popping up around today. And typically, like what we saw last week, we had a nice monsoon push. We got to be about 200% normal last week for what our typical moisture values would be this time of year. So we get that moisture push. Of course, you get lightning, you get heavy rainfall. Aviation concerns, you can get blowing dust, a haboob moving across. All of a sudden, your visibility goes to nothing. Your ceilings can be dropping. It can obscure terrain. Always want to be on the lookout for thunderstorms to make sure that you're not going to be in harm's way. So, as far as looking at what we have for thunderstorms, you can always check. You can check your local weather office. That works great. I know a lot of you have flight planning software as well that does wondrous things for you right on your iPad or your tablet. But if you want kind of a larger scale picture here, if you check with the Aviation Weather Center, you can actually look at their convective sigments, and they will highlight regions where thunderstorms are most likely. Also, the Storm Prediction Center. These people are experts when it comes to severe weather. They're the ones who do all the tornado watches. They're watching out for your severe weather across the country every minute of every day. But they will also be highlighting where the convective outlook is, where those chances for thunderstorms are. Things that you can do to look out for. How many of you have seen these altocumulus castellatus clouds in the morning? Those might look all nice and pretty in the morning, and you're like, oh, they don't have much vertical growth to them. That's not too scary, but they're usually a sign that thunderstorms are going to be developing later that day. So that might be something to kind of keep an eye out for, like, hey, if I'm making my flight plans, I might want to be on the ground before it gets to be afternoon and those thunderstorms start to grow. Towering cumulus, if you start seeing those, you're going to be dealing with probably some pretty strong updrafts. You may be getting to some turbulence. Another concern for you. Cumulonimbus, of course, that's the mature phase. You do not want to be flying under that thing. Heavy rain, hail, lightning, you can get downbursts out of this as well. And then under the you're way too close category, it's, yes, Mamata's beautiful to look at. They won't hurt you if you're on the ground, but if you're in the air, you're getting jostled around quite a bit. I see the nods. How many of you have ever flown in that? Okay, good. I don't want to see any hands there. But other things, get struck by lightning. You don't want to have the rain shaft because your visibility could go to basically nothing. You're going to be getting severe downdrafts in there. Now, as far as predictability, how many of you use our radar? Some? Okay. You know about our radar coverage is lacking quite a bit? It is. I'm fully admitting I know it. I wish we had more radars. It kind of drives us crazy too. But something to keep an eye on here. So our radar, anyone know where it's located? Top of Virginia Peak. So it's up at 8,300 feet, I believe. The reason it needs to be that high is because we have terrain all around this. If it was down low, the mountains would block things even more. But it's starting very high up, and it just keeps going higher as that beam shoots out, because it comes out basically at an angle, right? So if you're starting to see things close to the radar, you'll be able to see the bottom of that storm. As that radar beam shoots out even farther, though, you're now not seeing the bottom of that storm. You might be just seeing the top of that storm. So it's harder for us to see these things. So here's kind of our radar coverage. Green, great. You can have wonderful radar coverage. You get into those blues, yeah, blue-green, decent. More blues, grays, so sketchy. Good luck where we don't have any radar coverage. The good news is that we are actually a site that is going to be getting an upgrade to our software. Right now, the radar itself starts at a 1/2 degree elevation above the horizon, right? So it's already starting up a little higher. When this software upgrade takes place, we'll be able to move it down to basically be seeing at a 0 degree angle. So that is going to give us much greater visibility at longer distances and be able to sample storms a heck of a lot better. Plus, it will help all of you who are utilizing the radar data to be able to see things a lot more clearly for your flying needs. So here's another example of this, just for kind of situating yourself. That's Mammoth Airport, Mono County, Mineral. Here's Minden and Carson. You can see that radar loop, which stopped for some reason. Let's try that, see if it'll start up again. There you go. So does it look like anything's getting into Mammoth Airport right now? Or the Mammoth area? Down over here? No, it doesn't look like anything, right? But again, it's because of the lack of coverage. We have a radar gap down there. So clearly we were looking at web camera imagery here, and it's snowing, raining, stuff is happening. Our radar, once it gets down there, the absolute lowest that we can see is 19,000 to 28,000 feet above ground level. In the wintertime, storms don't even get that high. So we're not able to see anything a lot of times. It's just a really hard sell. Hanford's radar, though, we can actually use to see things down there a lot better. You're capturing things more 7,000 to 10,000 feet above ground level. So if you have radar options, you might want to be using the composite radar reflectivity, which is taking composite. It's taking all the radars in the area, basically stitching them together for you and showing you the overall picture, as opposed to just getting our radar where you might not be seeing something. So try to use a composite reflectivity and use a regional display. And all that is available. I'm going to actually hand you guys out some great information. It's all available on our website if you want to look at it that way. So let's talk about aviation specific. Now, as far as the Weather Service goes, there are a variety of aviation forecasts out there. We have the Aviation Weather Center, which is www.aviationweather.gov. If you want to have a one-stop shop, that is my most highly recommended page for you. You can get wonderful graphical forecasts, there's flight path planning tools, there's any number of things, and we'll get into all of that. The Alaska Aviation Weather Unit is basically just focused on Alaska, and I'm only mentioning it just in case you happen to have travels that take you up there. There are all the Central Weather Service units. There's 21 of those across the nation, and then there's the Weather Forecast Offices, which there are 122 of those across the nation. There we go. So the Aviation Weather Center is actually located in Kansas City, Missouri. They are one of 2 world forecast centers, the other one being actually in England. So they do forecasts for the entire globe out of that center. They have international desks, they have local desks, they actually break up the United States into various segments, east and west. And they do all the SIGMETs and AirMets. All of that comes right out of that office. They also maintain ADS, the Aviation Digital Data Services. Wonderful tool. Definitely recommend using that. And like I was mentioning, the flight path tool, the graphical forecast for aviation, helicopter emergency medical services. There are any number of tools that you can use off of this page. If we have time afterwards and anyone wants to get into it, I'm more than happy to go through the website with you and show you where you can get plenty of information, okay? So just as a reminder, a SIGMET stands for Significant Meteorological Information, and you're going to see non-convective ones, which is going to be for turbulence and icing. These are over rather large areas. We're talking 3,000 square miles or greater for looking at the regions. It's going to be for instrument conditions due to sand, dust, ash, and are issued on an as-needed basis for up to 4 hours. The convective SIGMET is going to be obviously for thunderstorms. You need at least 40% of an area covered in a 3,000 square mile box as well. These are issued hourly, 5 minutes before the top of the hour, and they're valid for up to 2 hours. And those are updated, like I said, really frequently since they are hourly. Now, the AirMet is the Airman's meteorological information, also out of the Aviation Weather Center. It advises of weather that might be hazardous, other than convective activity, mainly focusing on light aircrafts and pilots who are flying VFR. They're going to be issued every 6 hours and amended as needed. You're going to have your AirMet Sierra, which is for IFR conditions. You have your AirMet Tango, which is going to be turbulence, so you need moderate or greater turbulence for that to be issued, or you need wind speeds in excess of 30 knots at the surface, and I believe that they have that at sustained, not for gusts. And you also have your AirMet Zulu, which is for icing, moderate or greater threats, and also for freezing levels. All this you can get graphically on the Aviation Weather Center's webpage. You're able to actually adjust elevation, you can adjust location, you can get everything you need, and we can go through that at the end if you're interested. The Alaska Aviation Weather Unit covers a rather large area there out in the Bering Sea, up towards the poles, all of Alaska, and they have their own center because Alaska has 6 times the number of pilots per capita and 16 times the aircrafts up there. I've heard rumors that it's like 1 in 3 fly when you're up there, and it's just, there's no roads. Flying is a way of life. It's how you get around. They will do the same sort of things that you get out of the Aviation Weather Center, but it's for this specific area. And it's also one of 9 international centers that does volcanic ash advisories when we start seeing volcanoes impacting things around the world. The Center Weather Service Unit, as I mentioned, there's 21 of those across the nation. If you're flying locally, you're most likely dealing with Oakland CWSU, but if you're staying in the west here, there's several offices, Los Angeles, Seattle, Salt Lake, and then others as you fly east. These are co-located with the air route traffic control centers across the nation. They're actually a really small staff. There's usually 1 center manager and 3 or 4 meteorologists on station. So it's a fairly small staff. They do 2 shifts a day. They're typically not there overnight unless something major is going on and it's as needed. But they work directly with the flight controllers and helping them make decisions. So they have the most direct contact, I believe, with people who are routing air traffic across the nation here. They will be the ones issuing the center weather advisories. There are 1 to 2 hour warnings to advise of any kind of aviation weather criteria. So if you're going to be dealing with thunderstorms, icing, turbulence, reductions of visibility, things of that nature, they'll be issuing those as needed. And then the meteorological impact statements, it's kind of a strategic planning tool to help with routing traffic across the nation. So that'll be anywhere from a 2 to 12 hour forecast, and if it's expected to impact the operations anywhere in their service unit. Then we have the weather forecast office, and that's where I'm from. I work at the local weather forecast office. 122 of those across the nation. We issue the TAFs 4 times a day with amendments as needed. We do an aviation-specific forecast discussion. Highly recommend reading that. You can get into our heads. There's very limited things that we can put into a TAF, right? We'll talk about all that, but aviation discussion, we can put anything we want in there. We can talk about our confidence. We can talk about any number of things. And offices will issue soaring forecasts at a few locations. Obviously, Reno happens to be one of the ones that issues a soaring forecast. That is our office right there. We're actually on the north side of town. Anyone know where TMCC, DRI, all that? We're up there too. If you ever see a red brick building sitting on the south side of the hill with a big white dome next to it, you have seen our office. If you are ever curious, please give us a call. We would be happy to give you tours and show you what we have going on up there. I know some of you have been up there before, but you are always welcome. Just make sure you give us a call first. We do have security cameras and the guns come blazing if anyone shows up at the wrong time. No, I'm just kidding. But we actually do have security cameras. We are up there 24/7, 365, and do have a variety of interesting people that show up at weird hours of the night. So we like to be secure.
What's the dome for? The white dome?
That is actually where we release our balloons. Yeah, so we release, I have a video at the end just for fun, but We release weather balloons twice a day, every day. It's done across the nation, not just across the nation, across the world. 0 and 12Z every single day. It doesn't matter, rain, snow, sunshine, winds, all kinds of fun. And the video I have at the end of this, showing a release in high winds. Those balloons about 6 feet in diameter. So imagine taking a 6-foot diameter balloon and like 65-mile-an-hour winds, like holding that out your car window and keeping it under control while you're driving down the freeway. It's not particularly fun when that happens. Luckily, we have a few people who are really good at it. So our role, yes, sir.
What time do you release those balloons?
0 and 12Z are the official times. We actually released 1 hour before that. So this time of the year, we release at 4 p.m. so that it travels over the 5 p.m. window. They go about 2 hours long, hour and a half to 2 hours for the flight. And then when we get into standard time, it's at 3 p.m. and 3 a.m. You're welcome to come see a launch someday. Surprisingly, no one ever takes us up on the ones in the middle of the night. I don't know why. We're there. You guys want to come visit, don't you? No, not really. But our role is we want to just help people make good weather-related decisions. That's why I'm here. I want to be able to teach you guys where you can find this great information, where you can learn about local phenomenon that affects the region, because I want you to make great decisions as pilots and be safe when you're up in the air. We are one of 122 offices, as I mentioned. That little teeny area, I'll actually zoom into it so you can see it, is what we call our CWA. And that's just the area that we warn for. It's a county warning area. We are staffed 24/7, 365. Yes, we work holidays, we work nights, we work weekends. We're there all the time. It's a very interesting job in the sense that you're like, why did I get into this when it's 3 in the morning and you can't keep your eyes open? But it's because I'm not a night person, I'm a morning person. We also do that aviation discussion twice a day or more if it's needed. And that soaring forecast is issued by 7 a.m. at the latest every day. There it is. So that's kind of zooming into our area. We basically take from the Sierra Crest east. If you go onto the western slopes of the Sierra, the northern portion is done by Sacramento's office. The southern portion is done by the Hanford office. We go all the way up to the Oregon border, a little tiny portion of Modoc County there, out into central Nevada, and down into through Mammoth Lakes as well. Otherwise, other offices cover it. We try to collaborate. We want things to be as seamless as possible because you guys don't care about random geographical boundaries as you're flying, right? You're like, oh, I just crossed the Sierra. Well, I'm in Sacramento's area now. You don't care. You're going to want to just know, what is my route going to take me on? So now, how do we actually put together a forecast? We use this system called AWIPS. It's the Advanced Weather Information Processing System. Did you know that we are acronym central where we work? I guarantee. Yes, it's government, exactly. We have acronyms for everything. When you first start, you're like, huh, what? But you start to get used to it. We're going to use observations. We can get any number of observations from around the region. We're going to use forecast models, radar, satellite imagery, and we pull all of that into our computer systems, and we basically are looking at 5 screens every single day. 3 of them are devoted just to weather stuff. The other 2 are for internet. We can get a lot of information off the internet as well for forecast models. So I, for some miraculous reason, have not needed glasses yet, despite the fact that I've looked at all these screens for now 15 plus years. And my eye doctor keeps telling me, yes, someday it'll happen. So we have a beautiful new satellite. It's been up in the air now a couple years actually, but really just became official last year. GOES 17. Have you looked at some of the nice satellite imagery from this? It's amazing. It really is. I want you to kind of think of it as like old satellites were like black and white television. GOES 17 is like your high-def, 4K, ultra-high-def television, okay?
I've even seen cloud shadows on the ground.
You can see clouds, yep. It's so sensitive, we actually can do heat detection signatures. You know when they burn the man at Burning Man?
Yeah.
We can see it on satellite. You can't see the fire, but you can see the heat signature from the fire when they burn the man. That's how sensitive these are. Yes, sir?
Where'd you go to get those images?
I actually have did I link it? I don't think I did. I'm trying to think if I put it on here. You know what? Write to me, and I will be happy to send you a link. If you send me an email, because it's a very long email address otherwise. So why do we care? High resolution rapid scans. We are getting data every 5 minutes standard now. It used to be every 15 minutes. We actually have mesoscale sectors that can get us data every single minute. From 22,500 miles in space, we're getting minute by minute data at a very high resolution situation. If they overlap the mesoscale sectors, you can actually get data every 30 seconds. I mean, just think about the difference now. We're getting 30-second imagery versus 15-minute imagery. Much higher definition as well. You can actually see updraft formations and thunderstorms. You can see dust storms. You can see that wildland fires. A lot of times we see fires on our satellites before they're even detected or known about. So we will call the centers and be like, hey guys, we're seeing a hot spot. Do you have any record of a fire here? Making sure that they know about it. Now, lightning detection too. The satellites have something called the geostationary lightning mapper. So you're able to see lightning from above. So we're not seeing, our other sensors are detecting it from the ground. They're ground-based sensors. This is actually detecting it from above the clouds. You're seeing all these cloud flashes from above with it. It can definitely help on lead time with storms. And it also helps us in areas of poor radar coverage, which is basically the entire area. So until we get that upgrade. Also improves on the global forecast modeling that takes place. We're getting 9 to 10 times more data. Basically, it's processing a terabyte of data every single day. It's a lot of data coming through, and we have 16 different channels, plus ways of showing channel differences to be able to detect things better, like dust, like low clouds, like fog, being able to see differences with that. Other things we're going to use is something called a model output statistic, or MOS guidance. Now, that funny little chart's basically telling us temperatures, dew points, cloud cover, wind directions, wind speeds, all based off of regression algorithms that they can use based off of climatology for the local area and taking into account model guidance that's going into it. Now, Minden, we've already put in the request, but unfortunately these things take about 2 years to actually process because it's the government, nothing can ever go fast. Eventually Minden will have its own set of MOS guidance. Just know it's in the works. This is not the be-all, end-all, but it does help us out a lot when it comes to our aviation forecasts. So, as I mentioned, we're doing our forecasting now for the Minden Airport, but it's kind of on a trial run. We're using climatology, we're trying to use observations, we're trying to take the terrain into account and just learn about what's happening here. If you happen to notice something as you're using the new TAF, and you're like, my goodness, they are wrong all the time, please send me an email. Let me know what you're observing. You know, we're looking back. There's a staff of about 15 of us doing the TAF for that site. And if we can find things that are going wrong and then correct them, it helps us out. I'm not going to take offense if you're like, you guys just suck. What's going on? Maybe you can word it nicely, but just let us know what is happening and we'll be able to help try to figure it out and really refine it to make it a better forecast. Climatology tools are excellent for us. We pulled this into our system, again, because we don't have a lot of that guidance yet for the actual airport itself. But we do have wind climatology for every single month or by season or any other things at different times of the day. And we're able to pull, obviously we see mostly westerly wind events when it comes to the winter time frame. In the afternoons, during the summer, we tend to see those west winds again as well. We learned that overnight, a drainage wind off of the pine nuts tends to be a little bit stronger than what we were anticipating. We're seeing a little bit more off of that with the kind of easterly wind direction at night. We also can pull in the visibility and ceiling climatology to know if we're forecasting something that's just completely out of left field, or, hey, this climatologically makes sense. And guess what? Climatology doesn't always fit the bill, does it? We see extreme events, and we need to be able to forecast for that. But this at least helps us put things into perspective. Now, let's test everybody here. I'm going to have you guys shout out some answers to keep it interesting. Anyone need to like jump up and shake a little? No? Okay. Just making sure we're not falling asleep. So, show of hands. Everyone know what a TAF is? Most people. Okay, very good. Cloud values, MSL or AGL? Shout it out.
AGL.
Good. When are they updated? Standard.
6 hours.
Every 6 hours, exactly. 0Z, 6Z, 12Z, and 18Z. Now, locally, that translates to... Anyone? Thank you. -7 to -8, depending on time of year. How long are they valid for?
24 hours.
Yes. If I heard 36 out there, that is also correct for the core 30 hours. I didn't say 36. 30 hours for the core 30s. So those really major airports, Atlanta, New York, Los Angeles, Seattle, all these really big airports, they actually have 30-hour forecasts with standard 3-hour updates for them. What information can a TAF tell you?
Visibility,
Very good.
wind,
Yes?
Temperature, dew point.
Temperature and dew point are not in a TAF. No. It's in a METAR.
Winds aloft.
Yep.
Yeah.
Winds aloft are not in TAF. No. Surface winds are. Well, we'll go through it. We're actually going to talk about it too. What area does it cover?
the terminal area,
Awesome. 5-mile radius around the airport. And if there are thunderstorms in the TAF, does that automatically imply wind shear is present?
usually.
Yes. It will automatically imply that there is wind shear. Do you think that a TAF for one airport can be used for a site, say, 20 miles away?
Yep,
So it's a little bit of a trick question.
if it's close enough.
Yes and no. The distance doesn't necessarily matter as much as the terrain matters. So we have terminals at Truckee, South Lake, we're going to have one at Minden, Carson, Reno. If you overlay your little bubbles on those, they are all incredibly close to each other, right? But if you think about the appreciable weather at all these sites, huge differences. When Frank and Chris approached us about wanting a terminal for Minden, Frank did some great research just comparing Minden Airport itself to the Carson City Airport and was showing us just how different the two sites can be. Now, how far apart are those? There you go. So it doesn't always work using it for distance. Oops. So as we mentioned, the TAF. Your TAF is the center of that 0 to 5-mile radius around the airport. If you see vicinity, a VC in a TAF, that's 5 to 10 miles outside of that center point. Anything else theoretically should be covered in the discussion. Can't be in the TAF. Just kind of look at it like a donut. If you happen to like donuts. So, you're seeing something like this, and you're like, how in the world do I read this? Because I get that a lot. And I understand. When I first started writing them, it was like, okay, how do you process all this information? So just to start out, you're going to always have, and I'll move over to this slide for a second here, you always have your site located. So K, X, Y, Z. We're just making it up. KMEV, since we're here. The date and time that this is valid for, so it was issued on the 17th, and it was issued at 1721Z. It's valid from 18Z on the 17th, or excuse me, 18Z on the 17th to 18Z on the 18th. You get into your wind direction and wind speed, so southerly winds at 16 knots. P6SM just means you're able to see greater than 6 statute miles. VCTS, remember I was talking about vicinities that 5 to 10 mile outside of that? That's saying that there's some thunderstorms within 5 to 10 miles of the airport, but not necessarily on the airport itself. View at 009, what level is that? 900, good. And then if we have broken at 050 CB, that's your base of your cumulonimbus clouds, and then broken at 250, so broken at 25,000 feet. If you see a tempo, anyone know what a tempo group means?
Temporary.
Temporary, good. So these are conditions that should be occurring less than 50% of the time, but you might be seeing things going back and forth. One of the things I see happen a lot in the springtime, have you guys seen those kind of springtime showers that we get where it's like sunny, clear, and then all of a sudden a little snow squall comes through. Drops visibility, and then you're clear and sunny again. So think about someone like that. It's just these changing conditions that are taking place as the event goes on. They will never be more than a 4-hour group. And I try to encourage our forecasters never to put more than one in the TAF, just because otherwise it's a hard decision point, right? If you're seeing, okay, well, they're prevailing at this, but tempoing at that, what am I expecting? Especially if you're seeing, like, say, 4 tempo groups worked into your prevailing groups, it just gets very confusing. So use this as a planning forecast. It has strengths, it has limitations, but think of it as a planning forecast.
What was the 50% again? 50% occurring less than 50% of the time, or what?
Oh, if you're seeing tempo groups, it should be occurring 50% or less than 50% of the time. So your prevailing should be what's happening the majority of the time. right? So more than 50%, whereas your tempo should be happening less
So
than
in this case,
50%.
it's occurring from 19 to 22, like 3 hours of the 24-hour period, so it's less than 50%.
Oh, I'm talking about less than 50% in that window of time.
Oh,
So in that
gotcha.
3
Okay,
hours,
within
less
that
than
3-hour
50%.
window.
Yes.
Gotcha.
Mhm. Any other questions? Okay, just making sure. So, if you don't want to have to do all this decoding, and I think a lot of your flight software on your iPads and whatnot will do this for you too. Aviation Weather Center, though, you can enter any site you want, hit decode, and like magic, it decodes everything for you and writes it all out.
Jolly good.
So if you want to make your life easy and you don't want to have to think through decoding it, ta-da, it does it right there for you. So strengths of the TAV, it's concise, right? It's similar coding to a METAR. It takes our local forecast knowledge into consideration. It's a very common tool. And it's great for general planning forecasts. Half the time, there we go. But we can't put any kind of confidence detail. We can't convey any kind of frozen precipitation accumulation or icing concerns in there. We're unable to do timing, exact timing. Like we can do trends on there, but until we get closer to an event, you say a cold front's coming through. We can usually give you a pretty good estimation within a couple-hour window. But say we have a dramatic wind shift taking place, we're probably not going to know exactly when that's going to cross the airport until a couple of hours before it happens. So things like that might be a little bit off, especially as you're going farther out in time. And it's being asked to do a lot more than a few lines can do. You know, it's giving you surface conditions at one point. I think people are wanting it to do winds aloft, give you everything a METAR might give you a lot more information. But think of it as a planning tool, and think of it as a piece of information amongst a lot of other pieces of information that you can use. So the METAR. METAR is the actual observation on site. It's what's happening at the AWAS or the ASOS. Most of the time, these are automated observations. At a few sites, they actually do have human observers that go ahead and interfere and override what the sensor itself might be showing. Truckee does have observers during the day. Reno has observers on all the time. Other large airports most likely have observers as well. Same thing here though, if you want to get any kind of METAR information, you can get it off of the Aviation Weather Center page. You can go to any local page here. This is created by ads. You can see all the different METARs from around the area. You're getting your temperature, your dew point, your wind speed and direction. Lots of information, your pressure, altitude. You can get density altitude derived from all that as well. And sometimes there's remarks within the METARs, like remark, there might be cumulonimbus off to the distant northeast, or you might see some smoke and haze off to the distant south. Things of that nature. When you're seeing those remarks, most of the time it's because there's a human editing it and putting those remarks in for you. If you don't want to have to figure out exactly what the METAR is saying, there's that lovely decoding tool yet again, so you can have it break it down for you. Obviously the winds are kicking up back there. But see, this is an example of a rather complicated METAR here. It's actually saying 2.5 miles, there's thunderstorm with a little bit of mist, giving you your various clouds, giving your temp and dew point, your altimeter reading, and you'll see the remarks with the peak wind, lightning distant all quads, what time the rain began, continuous lightning, it's saying in cloud, cloud to cloud, cloud to ground. Also to the east, thunderstorm overhead, moving east, how much precipitation has fallen, 4,300 in that case. But if you don't want to have to learn how to read that entire thing, it just breaks it all down. Makes it easy for you. So to make life confusing, and I'm sure as pilots most of you know this already, but I just thought I'd just put it in there as a reminder. Charts and text sources are going to be using true north as a reference. The ATIS, AWAS, ASOS broadcasts, or any information typically given by the control over the radio is usually going to be in magnetic coordinates. So the wind direction over FAA radios is usually also in reference to magnetic north, at least from what I last was told. So, if there's anyone who wants to correct me, I know Larry there with FAA knows. So other things you can find off the Aviation Weather Center website, upper air charts. highlighting where various things are happening, showing you where like thunderstorm tops might be, where the jet stream is, at what flight level you should be flying for that. You can adjust, this is just showing upper level winds. You can adjust your elevation through here to see what the winds are doing, what the wind directions are doing at various levels. You can also get surface and low level charts if you want to see what's happening just at the surface here. So you can see kind of the low clouds along the coast. Really surprising, right? We get clouds along the west coast, never happens. But other sources that right through here, whether you're seeing lower ceilings visibility highlighted in those blues, and if you're seeing even lower ceilings there, you're actually getting into the red areas as well. Your surface charts can show you if there's any fronts coming through. You should know flying through cold fronts, you're going to be dealing with some shear, a lot of times wind, bumpy conditions, so you might not want to fly into that. Aviation forecast discussion, as I mentioned, if you want to get into our heads, read this. You can get to this from our local page, weather.gov/Reno, just click on forecast or discussion. Or if you're on the Aviation Weather Center page, literally you can go to forecast or discussions and it'll show you a map of the entire country. Click on whatever area you're interested in, it'll pull it up for you. So that's just another lovely piece of information right there. But we're going to be giving you information on things that we cannot put into a TAF or put into these really condensed little broadcasts that go out. We're going to talk about where our confidence is, where our uncertainty is. You know, flying around here, thunderstorms, how often do they happen at the terminal? Pretty rare, right? It's a very rare occurrence. But how often are they all around the terrain surrounding the terminal? Now, how are we supposed to put that into a TAF? Really can't. A lot of times if we're doing it far in advance, we'll be using VC just to indicate, hey, there's going to be thunderstorms in the area. But our confidence level on having them be really in that 5 to 10 mile radius outside, you know, it's like 50-50. But we can talk about it here. A lot of times we'll break out chances. Hey, at this airport, we're thinking it's going to be about a 30% chance of it being impacted or an 80% chance of it being impacted. Or hey, we're expecting our cold front to come through at this point in time. Your rain is suddenly going to turn to snow and start accumulating. We're expecting this much accumulation at this terminal. So just all of that information can go right into that forecast discussion. Smoke concerns also, we have ongoing wildfires, things like that. Put it all in here. If you have turbulence concerns, because you know, we never get turbulence here, do we? All the time. But also off of the Aviation Weather Center page, there is this graphical turbulence editor. Graphical turbulence guy, I can't remember what it stands for. But anyway, it's a graphical turbulence model, essentially. It doesn't have any human interaction here, but you're able to choose what size aircraft, light, medium, or heavy. And you can choose, is it clear air turbulence, is it mountain wave driven turbulence, or a combination of the two. And look at what flight levels you want to look at and find where your turbulence is. It's a wonderful tool. You can also go out in time and just see where things are highlighted. There we go. Trapped mountain waves are a big concern for us. I know our soaring community likes to ride along the wave. But if you are not looking for wave, or say you get trapped in something that's a little bit more turbulent than you might like, you can actually look for these visual clues here. We get these vertically propagating waves downstream of the Sierra quite frequently. Or you might see, anyone know what these are called? Got it. Think of it like you have two different layers propagating against each other, so it's almost like wave action in the ocean. So something like that, you're going to be getting a little bit bumpy if you're flying along. They're really pretty to look at, and they don't last very long, so you won't always see it, but you will be able to see these wave formations within the clouds. So remember we were talking about our pretty new GO-17 satellite? Let's look at some mountain waves and severe turbulence reports with that. This is actually water vapor at 3 different levels. So you're looking at low, medium, and high. Can you spot where the mountain wave activity is? Yes, anybody could probably look at this and tell exactly where the mountain wave is. Being able to see the ripples in the current downstream of the Sierra. If you go, I'm trying to think, I know you're asking me about the website. If you look up SIMS, do SSEC and SIMS, and do a search with that and GO-17, it might come up going that way. But that is something that you can look out for to know either if you want to ride the wave, if it's a good soaring day, or if you want to avoid the wave and don't want to get into that. Icing also comes off of the Aviation Weather Center's page. You can do probability or severity, or look at chances of various severities, 25, 50%, etc., and map it out for yourself. Look at the various flight levels and in and out of time as well. Luckily, this time of year, we don't have to worry about it so much. Once we get into the winter time, though, it's another story. So something else, another tool that you can have in your box to be able to pull out. Now, around here, we do get low-level wind shear quite often. I did a whole study on it at the Reno airport. I'd actually love to do it for many of our other airports, but I was using PIREPs to get the information. And honestly, I didn't have enough PIREPs for other airports to be able to do any kind of a study off of. Even with the Reno airport, it was fairly limited with the amount of data I had. Two types though, we have convective. If there are thunderstorms, it is implied. You're gonna have wind shear. Generally short-lived, radar is gonna be our best tool to detect what's going on there. However, we saw radar coverage is not great, right? So we don't always see what's going on. However, if we see anything that remotely looks like it could be it, we usually will call the airport and let them know ahead of time. That hope that they can get out on the radio and let anybody in the area know about it. The non-convective wind shear can last for hours. There's a lot of tools available to detect, whether it be through satellite. We actually sometimes can see it in radar imagery, but not as often. But ahead of time, we can look at observations. As it's ongoing, we can look at observations. Ahead of time, we can look at soundings, we can look at model data, and we can usually detect when there might be wind shear. So as I mentioned, convective, hard to detect. It's one of those things where you get those microbursts or downbursts coming out of the thunderstorm itself, which causes anybody on an approach to have a lot of problems trying to get into the airport. We've seen many an aircraft accident due to things of this nature. This is a wonderful video. This is actually from our friends at Las Vegas. This is looking at an actual microburst as it happens.
Oh, man. That's stunning.
So who wants to fly under that one?
Not.
No, right?
Not even the glider people.
I hope nobody would fly under that. Anyone want to see that one more time?
Yeah.
All right.
That's cool.
And things like that, incredibly common around here. Reason being, our thunderstorms, are they usually pretty high based? Like where the base of the clouds are. We tend to be very dry at the surface, we get high based thunderstorms, right? We'll get virga out of these thunderstorms. Sometimes we'll get some pretty good rain as well, but you might see that rain starting to evaporate as it comes down. Evaporation is a cooling process, right? As the air mass cools, it becomes what? Heavier or lighter than the surrounding air? Heavier! So it's going to want to sink, right? And say it has 10,000 feet of airspace to accelerate through as it sinks down. It's going to rush down to the surface and you get something that looks like that. You usually will see wind spreading out from a central point. A lot of times people will think that there is tornado damage because these wind speeds can reach 50, 60, 70, even 100 miles an hour out of them. But big difference here, you will see basically a central point and all the damage will emanate from that central point. Tornado, it'll be more of a spiral pattern and a lot more random.
Is it possible to run that in real time?
No, unfortunately, the video I have
How
does
much
not.
was it speeded up?
It was actually slowed down when the microburst happened. So if you look, there's a counter on the bottom here, so you can watch the actual time frame. All right, let's go here. So it starts about 6:30, and they slow it down there, and it is now 7:20. So it's about an hour long loop. But the actual burst itself was in about a 10-minute window.
That one could ruin your whole day.
Oh yeah, that will ruin your day.
The outflow winds, that thing would be terrific.
We get them here a lot. We get things like this happening a lot. And we can actually see when a thunderstorm collapses in radar, but we're getting scans about every 4 to 5 minutes out of these. That only took 10 minutes to take place. So what if we happen to miss the scan where that thing falls down? You're just going to see the outflow winds themselves, and it's by that point, it's too late if you're under it. That's why we really recommend do not fly anywhere near thunderstorms. So non-convective low-level wind shear can be from a variety of things. Mountain valley effects. We don't have any mountains or valleys around here, do we? Just a few. Lee side effects and gap winds, another thing that we get to deal with a lot. Fronts, also can deal with. And then low-level inversions here. So let's say you have winds screaming along at ridgetop level at, say, 70 plus miles an hour. At the surface, they're calm. There's going to be a boundary somewhere where there's going to be wind shear between those two layers. Now, if you see this in your TAF, that is your big flashing red light. Wind shear, wind shear, wind shear. It's happening. Unfortunately, it doesn't actually flash or turn yellow. It's just going to look like the rest of the text. But if you see a WS, we only do wind shear in a TAF up to 2,000 feet above the surface. So if you see WS, and then followed by whatever the number is, that's elevation above the surface. So at this point, it's 2,000 feet. If you go 005, it's 500 feet. We're mainly focused on low-level wind shear because it's the most detrimental to aircrafts. So that's what we're looking at. Again, convective, it's implied. We don't put it in the TAF. If you see a TS, just assume that there's wind shear present. If you see this, though, that means that we have something that's strongly indicating to us that wind shear is happening, or we've got a higher up that has told us that wind shear is occurring as well. Following the level that it's at, you'll see your slash, and then it'll be the direction and the speed following it. So, in this case, you're going to see the depth of the forecast and direction, your speed, and the speed itself is what you get at the top of the layer. So, it's when you break through that shear layer, what your speed difference is going to be. And a lot of times, again, we don't necessarily always have evidence of it happening at that point. We're using model verification and soundings from our balloons and things like that to try to infer that that is what is in fact happening. PIREPs, incredibly helpful for us. Please, please, please do not hesitate to submit a PIREP. We really like getting them, and then it helps us do better with our forecast because we get to get ground truth on or I should say air truth in this case, on what's happening. So we love PIREPs. Keep in mind that just because there's wind shear does not necessarily mean that there's turbulence. Yes, they can both occur, but in cases where there isn't mixing, there tends to be little or no turbulence. So again, you can be flying through underneath the inversion nice and clear, and it's when you hit that layer that you're getting that shear difference. If you're high enough up, it doesn't make much of a difference. Otherwise, other than noticing, you're probably getting a speed difference on your reading off your aircraft. But it's when we start mixing that we're starting to get a lot of the turbulence reports as well. And of course, we have our soaring forecast. So I've actually bounced around a few ideas, and no guarantees on this one, but I'm trying to think of ways to revamp it to make it better. I know I came and spoke with the Soaring Nevada group here. We're trying to recall if it was 2 or 3 years ago. But we talked about different things to add in. We can definitely add in the Minden-Tahoe once that gets going officially, come October 22nd here. But this is issued every day. It's by 7 o'clock in the morning, and it's giving you various indices, your winds aloft. Slide Mountain has data off of it. Sierra Crest isn't actually reporting right now. I'm hoping they get it fixed by winter time. Unfortunately, some of these remote mountain sites are not ours directly. We're using the data. So if they go down, I apologize. We can't necessarily fix them because it's not ours. We have to wait for somebody else to go and fix it. If you ever notice anything wrong with the forecast itself, or if it's not out for some reason, please give us a call at the office. We are more than happy to help you out. We do issue this at the very end of our midnight shifts, and most people are not particularly awake at that point of the night. I'm one of the weirdos that, once it gets to be about 5 a.m., I wake up again, because that's my normal. Usually I put 4 or 5 in the morning if I'm not on a night shift, so I wake up. Other people, though, by about 5 a.m., their brains shut off. So give us a little slack. We do the very best we can, and if you ever see anything that doesn't look right, please do not hesitate to let us know. Anyway, some of the things I was bouncing around, though, idea-wise, and since I have a captive audience, I'd like to see if you're interested in anything, and I can't make any promises that we can make this work, but these are just thoughts that I've been bouncing with. How many of you would be interested in something that would be more graphical as far as a soaring forecast, kind of showing these parameters, but more on a graphical view? Some? Yeah? Okay. I know I was given kind of the soaring windows that Minden typically flies in. I'm wondering if we could do something page-wise that pulls in data that has it broken into these groups and is more of a graphical in addition to doing a text forecast as well, so you can kind of get both routes of information. But if there's an interest, I'll definitely look into it and see. Unfortunately, I'm not a master computer programmer like some of the people in our office, but I do have friends who know how to do that stuff. So I'm hoping our team can possibly come up with something. Yes, sir.
If we pull up the sounding, SKUT sounding
Yes.
for Minden, is that data extrapolated from your balloon
No.
launch in the morning? Where does that come
A model, a forecast model.
from? Model,
Yes.
okay.
Yes, so soundings themselves will go into the forecast models, but if you're getting something, say, prior to when the sounding will be finished, it's going to be based off of the previous one. So all the information is ingested into the model, but it's a model-derived sounding, if you're looking at anywhere besides Reno, or the other locations that we've done, I should say. So kind of breaking it down, and most of you, since you are well-established soaring pilots, probably already know all this, but I'll just go over it for people who are in the audience. If you're looking at this, the max temp is just the max temp that's forecast for the day. We do the today and the yesterday to compare. The trigger temp, and again, I'm not a soaring pilot, so this is what I've either been data I have found in books or I've been told. So if I'm wrong here, please do correct me. I will not take offense. But trigger temp is when a minimum lift rate of 260 feet per minute would be obtained. The maximum altitude is basically determined from the high temperature, and it's by FAA regulations topped out at 18,000. So if you never see it go higher than that, that's why.
Now, that forecasted maximum altitude, is that supposed to be the top of the boundary layer?
I actually do not know.
We'll see days soaring
Yeah.
around here where cloud base is not even
Close to that.
close to that.
I will have to look into that one. I know that this script was put together, probably 25 years ago. 25 years ago.
Doug Armstrong.
Yep, exactly. Because of Doug. And honestly, it hasn't been updated in forever. That's why I was asking. I'm like, so what else would you guys like to see? Can we update this? Can we make this any better? What can we do with this?
Do you know, how localized is it to Minden Airport? I mean, if we compared these values with what happened over Bridgeport, happens over Bridgeport, would there be much difference?
I think it would be pretty similar overall, especially since you're dealing with the air profile aloft. The only time I would see something different is if, say, we have a frontal boundary or something that gets stalled out and it hasn't made it that far south yet. But otherwise, I would say probably should be in the same general ballpark.
One of the things that would be, I think, would be useful to soaring pilots is to know where overdevelopment, where thunderstorm potential is reaching 25 and above index. And comparing, say, the air sailing area with the Bridgeport area, because fighter pilots are trying to make a decision at 11 o'clock in the morning, are they going to go north or south?
Gotcha. And I think that's where the graphical would come into play really well, because you could actually highlight larger areas as opposed to more localized.
Yeah.
Okay, I will put that on my list of things to look into. And those of you who are here from the Soaring Nevada group, if you want to all meet up with me at some point too to discuss this, talk about things you're looking for, I think it would be a great meeting, and we can probably at least get some better ideas then where to go with that. So let's talk afterwards and get it together. K-index is basically just the thunderstorm potential parameter based on temperature, lapse rate, and moisture content. These are just kind of really rough indications. 25 plus thunderstorm potential, 35 plus flash flood potential. Lifted index is just an atmospheric stability parameter. These are, again, just rough indices that I was finding out here. I'm sure you've developed your own localized knowledge that tell you better indices, but just know that if you start getting negative, you have better thunderstorm potential. Now, as far as kind of our real-time decision support, we actually do briefing emails and webinars for all of our key partner groups. I know with the TAO coming in now, you guys are on that list. So they are able to have insider information that you guys probably could be privy to as well, depending on whatever. It's all free to share, so feel free to share stuff. Okay, just kidding. Chris knows nothing about this. But we do a freak out chart basically showing the next 7 to 14 days and highlighting, just color coding what things to look out for. You know, green means, hey, all good. Red, you're starting to get into some pretty high levels of freaking out here. But it's just a simple way of looking at things. We've done other really funny things like the wine scale. How many bottles of wine do you need to survive the winter storm that's coming in? Unfortunately, our region didn't particularly like that, but we thought it was pretty funny. And then the trash can scale. How windy is it going to be? Am I going to have to pick up my trash can in the next county, or is it just going to roll down the street? So we like to try to keep it real, try to keep it interesting, and not bore you guys with just like, okay, here's your forecast, go along. You know, we want to make it fun. Also, snow projections. You know, I was talking about various scenarios. We can discuss kind of, hey, if it goes this direction, it could be one thing. If it goes this direction, it could be another thing. Because, like I said, our forecasts are a forecast. We're not perfect. We know this. We do the very best we can with the data we have. But things get updated, things change. And we'd like to be able to give the scenarios to our core partners so that they can make the most informed decisions that they can. Other ways to get information. Social media has become a huge thing. We also do weather stories on our website. If you want a quick and dirty, hey, what am I looking at today? Look for the graphic. We usually just try to put the key messages right up there so that you can see it. Now, as I promised, so this is actually from our office. That's our, if you see the white dome, that's it. This is a balloon launch on a windy day. That's actually Scott. He is an expert at doing these high wind launches. We've known him a long time. But take a look at how this goes. Come on, you're not going to play for me. All right, well, if that doesn't play, I have another way of making it work. Here. Maybe? There it is.
Wow.
And yes, that we celebrate afterwards, okay? You sometimes drop to your knees and you're like, thank you, it worked. Because it's not exactly easy. Well, look at that one more time. What do you think? Should we watch that one more?
Yeah, she has a runway for that.
Yep, so we have this gravel runway, if you will. Now, that's basically going to the east, and we have a drop off at the end there, so we kind of just try to let it get as far as possible and then throw the thing so that it doesn't hit anything. If you have more southerly winds, it's more of a problem because basically looking this way would go north. We have a little ridge line right there, so it can hit that. If we have winds going from an easterly direction, we launch off the other side, but then you also have a bunch of towers and antennas and the weather building itself. We don't want to hit any of that stuff. So yeah, the west winds tend to be best because we actually can get them to go off in that direction and hope for the best. Some scary things that have happened though, winds have wrapped that string around arms, hair. Yeah, if I remember doing a high wind launch, I literally will like put a beanie on or put my hair in a bun or something because I don't want it to get wrapped up in there. But that's what it's like taking a 6-foot diameter balloon out on a 65 mile an hour wind day. It's not particularly fun.
Filled with helium?
Good question. It's actually filled with hydrogen.
Oh.
So we have a lot of hydrogen safety in place. We have grounded mats. We have all kinds of valves and things to keep it as safe as possible in there. Helium, as you know, is a heck of a lot more expensive than hydrogen. So we do a lot of hydrogen safety, but we do use hydrogen.
So 700 of these a year, huh?
Where
do they end up?
So what's prevailing winds here?
From the west.
Yes, west to east, right?
There's a guy out in Battle Mountain
Yep.
who sells hubcaps, and he also sells these.
Yes. So most of these do end up to the east because the prevailing winds are westerly. The songs and the blue and everything else, the parachute that's attached, it is biodegradable. But if you happen to find them soon enough, there is a little mailing envelope attached to the instrument, and you can actually put it in there, send it back in, and it can get reconditioned. Pretty much every year, someone will bring one back from Burning Man. A lot of times we'll find firefighters will bring them back from fighting forest fires. They're usually a little bit crispy at that point. But other times, yes, we see them on eBay showing up where people will be selling them out of their garages or who knows what. But they do float safely back to Earth with that parachute. Or at least most of the time they should be safely floating back to Earth. Let's go back.
So the use of hydrogen in lieu of helium is strictly an economic reason.
What else did they measure?
very good question. So it has a thermometer on it, so we get temperatures the entire way up. It also has a humidity sensor, so we can infer dew point. So we get temperature and dew point. We use GPS tracking to get wind speed and direction off of that. The instrument itself, like I said, it gets put up every day, twice a day, across the entire world at the same time, and it all gets fed into the models. From those few parameters, we can actually derive a lot of other parameters as well. We're also getting altitude, pressure, getting to see the density, a lot of other things off of it as well. They are instantaneously fed back to the office. The flights tend to last anywhere from about 90 minutes to maybe a little over, maybe like 100, 110 minutes, so close to 2 hours. They will go up about 100,000 feet in the air before the balloon itself pops. The balloon, by the time it pops, it starts out about 6 feet in diameter. If you're familiar with the ideal gas law, if pressure decreases, what happens to volume? Increases, right? So that balloon, by the time it pops, is usually the size of like a large 2-car garage or maybe even a small house. I don't know, there's varying theories on it, but that's what I've heard. And a lot of times it will just pop and shatter because it's pretty icy up there by the time it does pop. We're able to detect where the inversions are. We can see what's happening at ridgetop level. There's just like an invaluable amount of data that we can get from these though. But standard is twice a day, every day. We will do special releases if we're expecting a really active thunderstorm day. Around here, pretty infrequent. We might do 1 or 2 special releases a year. A lot of times the agency will ask that offices do extra sounding, say every 6 hours ahead of a big atmospheric river, or if we're looking at a big severe weather outbreak or hurricane or anything like that, because you want to get extra data put into those models. And with that, I'll just, time to ask me pretty much almost anything.
Can you talk about the difference between from and becoming in a TAF?
Yes. Well, becoming is used very, very rarely. A from is going to be, I'll put it this way, I have in 15 years never used becoming, ever. That's how rare it is. But it's going to be essentially inferring almost the same exact thing. It's going to be saying, hey, at this time, it's turning to this. It's just a nicer way of saying, instead of just saying at this time this is occurring, it's saying it's going to be becoming this at this time. It's almost no difference.
I see them a lot in commercial aviation, but
Okay.
what I remember was something to the effect that becoming might just modify, say, cloud cover, whereas the wind forecast from the base forecast would still carry over to that same time period, different from the from, which is an all-new change in
Yes.
the prevailing conditions. Is that right? Something
That would work. Yes, that actually would be true. Again, for commercial aviation, they do tend to write their own TAFs. Sometimes it'll actually differ from what that WS TAF is. They will use that probably a lot more frequently. In 15 years, I have never once used becoming in a TAF, ever.
Maybe that's WSI I'm thinking of.
Yes.
See it becoming a lot.
Yes, so that can be used for kind of like a gradual change, as you mentioned with the clouds.
Occasionally, the Navy Fallon TAF is considerably different. Do you share information with the military, or is it theirs derived?
So they do their own TAF forecasting for their specific aviation-centric area. We actually do not do any kind of forecast for Fallon itself. So they will just forecast right for there. We do talk to them. They actually have their own radar and everything right on their field. So those are the things that, I guess we will share information, like if our radar's down, we'll talk to them, but they tend to have their own set of rules for military forecasting, and we do not go across.
Okay.
Yes.
Out in Colorado, in a number of passes, they have ASOS type weather frequencies with reports on, this pass or that pass. Has there ever been any discussion to have one of those kinds of things along these ridges out here?
Like as far as an ASOS along the ridge lines?
Right.
So, yes. There's actually, the Truckee Airport has been trying to get one up on an AWOS or an ASOS on the ridgeline for years now, unsuccessfully. Because of a lot of the lands being more federally owned out in the west, it tends to be a lot harder to get them up on there. I think it has been desired but the monetary restrictions on it haven't allowed it to happen. Now, as far as actual weather observations, there are mountaintop weather observations. They're not AWOS or ASOS. They don't have frequencies, but you can access the data online. I can actually show you. Do I have internet on this?
I think so.
Okay, let's see. Yep, Slide Mountain is one of them. Just, oh no, let's use Chrome. I like Chrome a lot better. Come on. Oh, doesn't want me to use that. Okay, well fine, I'll use Internet Explorer. And the other thing with the ASOS, typically they are maintained by the Weather Service offices. Whereas a lot of these sites, so if you go on our website and you look at current conditions here, and you want to go local mountain observations, and you can get text versions of these as well, but there's a whole variety of sites that you can get right off of here.
What did you get to this?
Weather.gov/Reno. And then, actually, I'll go back. Go to current conditions, the drop down, and choose local mountain observations. And if you want to choose the site directly, let's just use SQUA as an example here. You can see the graphical one. You can see the wind speed and gusts. You can see the direction forecasts. Excuse me, not forecast, observations. There hasn't been any precipitation. That's another thing you can look at. Or you can also look at the text version of it, which gives you the raw data. It's basically every 15 minutes it gets updated. Another site that you might want to use is, and this is unfortunately, I can't just type it in very easily, but so if you want to go to MesoWest, and then you choose our local area, and instead of just NWS, you'd want to choose all networks, and refresh your map. Actually, let me choose that instead. This way, this will get a little convoluted because you need to know what you're looking for. But that actually gives you all the observations in the area. So you can just kind of scroll over, there we go, and get what's going on. So you want to pick up stuff over here on Slide, there's Slide for you. And you click on it, you get a graphical, or you can also pick up in text what's going on. The other really nice thing here too is if you want to look at a different date, you can do change date and time, and you can go back in history and find out any information you want off of there. It's one of the things I used when I was doing my wind shear study. I looked at PIREPS, then I went back and I used MesoWest to pull back data on what was happening those days. Get the information. Now, I know we've been, let's see, it's almost 2:30. Do you guys want me to show you some of the fun stuff off the Aviation Weather Center page? Do you want to wrap it up? Any other questions, actually, too?
Just out of curiosity, where did you get your degree from?
University of Arizona.
What kind of temperature changes have you observed over the years?
You mean overall trends?
Trends, yeah.
So the trends, you're talking kind of climate data. Put it this way, like this summer, for example, everyone kind of thought it was a cold summer. And I haven't looked at since summer, the official meteorological summer ended, but we were still in the top 15. But the past 3 summers before that were the top 3 out of 4 as far as hottest summers go. We have seen overnight low temperatures on an increase. Greatest, of course, where we have populated areas, just urban heat island effects, but we have a whole network of cooperative observers basically these volunteer weather observers that are in rural areas as well. We have seen an upward trend there also. There's probably been a little bit stronger of a correlation in the overnight lows than there has been in the high temperatures, but a general warming trend, at least as of late, has been occurring. The new climatic normals are actually going to be computed next year. This is our final year for it. They're done every 10 years. It's a moving 30-year target. So I think we'll be able to see more of the trend data once that gets computed next year. Anyone else?
What happens if you hit one of those weather balloons that flew by one about 20 feet away?
Oh my goodness.
1,000 feet once?
So we recommend not hitting them, obviously. We actually do, we call the airport every single time before we launch. We talk to the tower, tell them, hey, balloon is expected to go in this direction. Are there any aircrafts in the air, like in the way? And they'll give us a go or no go, or hey, can you wait, etc. I got a call from Fallon just last week asking if our weather balloon got into their airspace. I was like, well, it's possible, but can you tell me what time of day? Because we've had other times where people thought it's ours and they weren't our balloons because they didn't correspond with when we would have released. As far as flying into them, I would guess it's not a good thing, but I'm not exactly sure what the exact.
How much does the sensor part weigh?
Not very much. It is, so we usually use about 1,300 grams of hydrogen to lift the whole thing. So it's a fairly lightweight piece of equipment. It's more just, you don't want things getting ingested into like a jet engine or things like that. Anyone else? Well, thank you very much for being a wonderful audience, and hopefully this helped you learn a lot more about all the different aviation products and local hazards that we deal with. If you want to stay, ask me any other questions, want me to show you anything on websites, just let me know. And again, it's dawn.johnson@noaa.gov. Feel free to send me an email if you have any questions. I also have a few cards up here if you need a card. Thank you all. I appreciate your time.